Okay, so here we go. We're going to do Algebra 1, Unit 2, Lesson 4. Okay? All right, today we're going to really work with literal equations. And when we work with those literal equations, let's just remember what literal equations are. So literal equation is an equation with more than one variable. Okay, so you're not just going to get at the end like x equals 7. Okay, you're going to have multiple variables in that answer, and we got to get comfortable with that. Okay, so an example of an equation we have been solving. So 3x plus 9 equals 15. Okay, well, if we were going to solve that, we could just solve that for x. And in the end, when we did minus 9 to both sides, we get 3x equals 6. Divide by 3, x equals 2. So here's the whole point. You get a variable equals a number. When you see a literal equation, here's an example. ax plus b equals c. There's more than just one variable in that equation, okay? So when we solve for something, we're not just going to get like a nice clean number like what you're used to. You're going to have a variable as part of the answer, okay? So it's more just about getting comfortable with it. So let's compare the two. So here we minus 9 to both sides, okay? So I get 3x, 15 minus 9 is 6. Well here, let's minus b to both sides. Now the difference here is I can't actually do c minus b. So I just write c minus b. So here I could do 15 minus 9. Well, here I can't, so I just write it. Well, now, what's the 3 doing with the x? It's multiplying, so we're going to divide by 3 on both sides. Well, here, what's the a doing with x? It's multiplying, so we're going to divide by a on both sides. So now I'm left with x equals 6 divided by 3 is 2. There's my answer. Here, this cancels. A equals c minus b over a. So that's the example of the type of answer you get with a literal equation. Again, be okay with getting something that's not just, it's a number, okay? So let's just show a few more where we show that the steps really are the same, it just leads to a different looking answer, okay? All right, so for instance, here I have x over 5 minus 8 equals negative 4. So I have a minus 8. To cancel that, I'm going to add 8 to both sides. So I get x over 5 equals negative 4 plus 8 is 4. So now I'm going to multiply both sides by 5. When I do that, I get x equals 20. Okay, well now let's show the same steps. I had minus 8, I added 8. I have minus h. Well, I'm going to add h. So I get x over 5 equals b plus h. Well, now what did I do? I multiplied by 5. Okay, well let's multiply by 5. Cancels here. 5 times b is 5b. 5 times h is 5h. So x equals 5b plus 5h. There you go. I see 4x equals 20. Well, what's the 4 doing with the x? It's multiplying, so let's divide by 4. So I get x equals 5. Well, here I see jx, so I'm going to write x equals divide by j, p divided by j. And again, be okay with getting that type of answer. We did the steps. We just don't know what p is, we don't know what j is, so we can't actually divide them, so we just represent it that way. Okay? Alright, so then from there, again, same scenarios, same steps. So notice, 4x plus 12 equals 2. Well, I want to get x alone. 2x plus 6y equals 10. I want to get x alone. So what do I have? I have the plus 12. Well, let's minus that, right? Well, here I have plus 6y. Well, let's minus that. So here I get 4x equals 2 minus 12 is negative 10. Here I bring the 2x down. Now the difference here is 10 minus 6y. I can't actually do that, so I just write 10 minus 6y. Okay, next I see 4, so I'm going to divide by 4. Well, negative 10 divided by 4 is negative 2.5, so I just write my answer. Well, over here it's times 2. Well, I'm going to divide by 2. 10 divided by 2 is 5. Negative 6y divided by 2 is negative 3y. So I get x equals 5 minus 3y. Okay? So again, notice I wasn't able to combine the like terms, and that's okay. I did the steps correctly. All right? So lastly here, I see 1/4 x equals negative 6. Well, I'm going to multiply by the reciprocal, 4 over 1. Multiply by the reciprocal, 4 over 1. Left side it cancels. X equals negative 6 times 4 is negative 24 divided by 1. Well, remember, anything divided by 1 is just itself, so we just get the answer. Okay, over here, 1/4 x equals t, so I'm going to multiply by 4 over 1. I'm going to multiply by 4 over 1. Cancel, x equals, well, t times 4 is 4t, and then hopefully you realize you don't need to put divided by 1 because it's just the same thing, so then there we go. Okay, last set of examples here. Let's show with the multiple step. So I see 3/4 x plus 5 equals 10. So I'm going to go minus 5 to both sides. 3/4 x equals 5. Well, now I see 3/4 x plus g equals k. Well, I'm going to go minus g to both sides. So 3/4 x equals k minus g. I can't actually do it, so I just write k minus g. Now I see the 3/4, so I'm going to multiply by the reciprocal, so multiply by 4/3. So it cancels on the left, so here we go, 5 times 4, 20 over 3. You are totally good, so just leave your answer straight like that. If you don't like that and you want to divide it and get x equals 6.6 repeating, sure, you can feel free. Now I'm going to multiply by 4/3 here to cancel for multiplying the reciprocal. So now I cancel the left, I get x equals, and we could just leave this as the answer. Okay, 4/3, so 4/3 times k is 4/3 k minus 4/3 g. Okay, now last but not least, let's look at this example. I see 3x plus 4 equals 12, and I see a x plus b equals c. So I'm going to distribute, so distribute. So 3 times x, 3x. 3 times 4, 12 equals 12. Minus 12 minus 12, 3x equals 0. Divide by 3, divide by 3. Well, anything divided by 0 divided by anything is just 0. So x equals 0. Okay, distribute, distribute. A times x, ax. A times b, ab equals c. I want to solve for x. So here we go. Minus ab minus ab. Ax equals c minus ab. I want to get x though, so I'm going to divide by a everywhere. Well, c over a is just c over a, and now check this out. I've got ab over a. We'll just cancel those a's, minus b. Okay, so we solved here multi-step literal equations. Literal equation meaning it has more than one variable. Be comfortable with getting an answer that has more than one variable because our problem had more than one variable. All right, this is Algebra 1, Unit 2, Lesson 4.